All right, that's the polymerization of a thing. Look at it there. That's a polymerization reaction. N can be any value. All right, so that's the polymerization reaction. Okay, ethine also polymerizes. Okay, when passed through a red hot tube to form benzene. Another Jamb question. Take note. The way they ask it is when you pass ethine through a red hot tube. All right, what do you have at the end? You have benzene, 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 benzene. Ethene polymerizes to polyethene. Ethine polymerizes to benzene. Let's take note. Passing through a red hot tube. These are questions in between lines. Most of the questions Jamb asks are in between line questions. They may not come directly. They will ask you a direct question in an indirect way. Quickly, isomerism. What is isomerism? From the name, iso means same and mer means part. So isomers are different compounds having the same molecular formula. They have the same molecular formula. They have the same structural formula. Don't forget, in your basic secondary school, SS1 rather, or SS2, you were taught that the simplest formula of a compound is its empirical formula. Why? Because the empirical formula of a compound expresses that compound in the smallest possible ratio. For example, C2H4 is not an empirical formula. Rather, it's a molecular formula. Why? Because I can still break down that 2 and break down that 4. So C2H4 is not an empirical formula, but CH2 is an empirical formula. CH3 is an empirical formula. C2H3 is an empirical formula, the smallest possible ratio. So isomerism just means different compounds of an hydrocarbon, okay, having the same molecular formula but different structural formula. The structure is the difference between the compound. Look at the first example I gave you. When butane and 2-methylpropane. Do you see it now? Butane is a straight chain compound. 2-methylpropane is a branch chain compound. Why? Because it has an attachment. When you have an attachment, you have a methyl group, methyl. You have a methyl group attached either upward or downward to a straight chain compound. The compound becomes a branch chain compound. Are we together? So, isomerism deals with compounds having the same molecular formula. That is the normal formula I have for the straight chain compound C2H4, C3H8, and all of that, but different structural formula. So if you are dealing with the structural formulas, you'll be having compounds that have attachment attached to it, or having compounds that have attachment. Pardon my English. Compounds that have attachment. All right. There are two types of isomerism. We have okay, before I go into that, we'll see that the existence of this compound with the same molecular formula but having some physical and or some chemical properties. Can you see it now? Isomers have the same chemical properties. The same chemical properties. All right. So the types of isomerism, we have structural isomerism. In this case, the compounds have the same molecular formula but different structural formula. And we see butane there, C4H10. The first isomer is the butane itself. CH3, CH2, CH2, CH3. They've broken down the C4H10. If you want to break down an alkane, how do you start by breaking it down? It's always, first of all, CH3. Or you write the number of C's it has first. Then you put an arrow in front of the C, under the C, and above the C. You're going to be having CH3, CH2, CH2, and CH3. Are we there? So that's butane and 2-methylpropane. Have you seen it? All they needed to do was to bring out one of those CH2. Look at it. You have CH3. Then they brought out one of the CH2. Remove an hydrogen from the remaining CH2. Then you now have CH3. The diagram is very explanatory. You now have CH3, CH. Then the H removed from the second CH2 was added to the other CH2 removed, and it became CH3. So you have CH3, CH attached below CH3, and forward CH3. And how do you name the compound? How do you name compound? Let me start. Okay, the analysis from here. Okay, you can start forward from the left to the right or from the right to the left. The only thing you're going to look at is that if you are starting from the left to the right and from the right to the left, check which arrangement gave you the least possible number. Which arrangement gave the least possible number to the attachment. That is the direction you are going to follow. Okay, this one, if you go forward, you have the attachment will be on number 2. If you go backward, it will also be on number 2. So assuming if I go forward, the attachment was on position 3, and when I go forward, the attachment was on position 4. I will go with the arrangement that gave position 3 to the attachment. So you can name forward to backward or backward to forward. There's no fixed method of naming. You can go either forward to backward or backward to forward, as long as the attachment is giving the least possible position. All right, so that's it. Then pentane also having 3 isomers. Pentane is the first one. Then the second one, which is the N-pentane. The second one is 2-methylbutane. The same process. Remove one of the H2, remove the H, just the same way we did the first one for butane. Then you also have 2,2-dimethylpropane. Pentane has 3 isomers. I think before the class is over, I'll send us a table that contains the compounds and the number of isomers they have.